I would like to just welcome our speakers once again. And with that, I can start with my introduction. And I'm Vanya. I'm the head of technology for Thoughtworks India. And now I'll ask the fantastic speakers to introduce themselves. Neal, do you want to go first?
Sure. Thank you so much, Vanya. My name is Neal Ford. I'm a director at Thoughtworks. I've been at Thoughtworks almost 17 years now. And this book is my 9th book. My day job at Thoughtworks is the intersection of software architecture and engineering techniques, which is exactly where this book came from. And I'll let Mark introduce himself.
Right. Welcome, everyone. I am the non-thought worker here. So I just want to make sure that folks know I get so associated with Thoughtworks because of my association with Neal and a lot of things I do. But anyways, my name is Mark Richards. I'm an independent consultant, actually, and a hands-on software architect. And about for the past 7 years, I still do hands-on consulting, but I've been doing a lot more in training and conferences and writing books with my friend Neal. So I haven't quite hit 7, Neal, or however many yours is. I think I'm only up to about 6 books, I think, but I'm trying to catch up to you. But the problem is, Neal and I write so many books together, I'm never going to catch up with you. So,
well, I figure as long as I keep writing them with you, you're never going to catch up with me. So I'm pretty safe.
That's right. But anyways, I'm also, just to finish up my introduction, I've been in the industry since, well, for about 36 years now. So lots of experience. And about 4 years ago, I did find a website. I'm founder of a website, developer2architect.com, which kind of helps folks in the journey from developer to software architect. So that's a good resource to check out.
Thank you so much, Mark and Neal. I'm sure our audience are going to check out that website, Mark. I'm sure they already know about that. So without further ado, I think I would like to just start bombarding with you two with a few questions. And the first one that comes to my mind is, I believe, as you just disclosed about your book tally, right? Both of you have written and spoken about software architecture extensively. Why do you think it's important?
Wow, you want to start out, Neal? Or?
Yeah, sure. I'm happy to start out there. So why it's important, I think the thing that let everybody know that software architecture was important again, it's always been important, but when microservices started getting all the press and people started looking at the success that companies like Netflix and Uber and other companies were having, Amazon, and they realized again, this cycle happens over and over, that if we use software architecture in a really clever way, it can become a business advantage. It becomes strategic and not just overhead. And when people realize that, they realize that, this is yet another way that I can get ahead of my competition. If they're viewing software as overhead and I can use it strategically, then that's a way for me to get ahead in my marketplace or, gain a leg up. And so I think that really gave visibility to software architecture. It's always been there underneath. And, we've always been thinking about these things, but that made it sort of, in everybody's face all of a sudden. And, Mark and I talk about, I think microservices also gave a jolt to software architecture because it's so difficult to get correct. And, that there are so many difficult choices there that they realize that, there has to be somebody there to do some serious analysis to be able to get that right. In fact, Mark and I did a lot of development in distributed systems before. And when we started looking at microservices, we realized that it was a lot more complicated because of the data and the data fidelity that gets added. So I think that's why it's still a hot topic of conversation.
Yeah. Well, also, the thing about this is both of us have so much knowledge and experience in software architecture. And we just felt, as a matter of fact, I think, Neal, what was it, almost over 10 years ago, that, it's really important, we felt, just to kind of make sure we spread that knowledge and information to others. As a matter of fact, one of the quotes that I like to say, and as a matter of fact, this was one of my drivers in moving further away from consulting, like actually being on a team developing code as an architect, to training, was really that passion about the fact that spreading knowledge is far more valuable to me than being an individual contributor, especially after you start getting older, like me, and start amassing all of this knowledge. And I think that was a real driver about just how much we've written and spoken about software architecture. You know, it also helps being passionate about the topic as well, which both of us are.
Absolutely. I think I love that quote, Mark, that you just mentioned, that your move from consulting to, training. I think that shows your passion, that you want to spread, both of you want to spread your knowledge with more and more people. And with that, I want to segue to our next question. And I encourage our audience as well to please, dump in their questions in the Q&A tab. But that gives us a segue to the next one, which is, why do you think, or why do you rather believe, all software developers must read this book? Anyone wants to start with that?
Yeah, actually, that one's easy because we spent a lot of time writing it. No, really, this book is about software architecture and the hard parts there. But we really do feel, at least I feel, that all software developers should read this. And it's for a couple of reasons. It's, we tend to think about only architects can do what's called architectural thinking, seeing things with an architect's point of view. And well, I don't necessarily agree with that. It's certainly the responsibility of an architect to think architecturally, but why can't we start doing that as developers as well? And part of that architectural thinking is all about trade-off analysis, seeing trade-offs in everything that we do, and also knowing how to analyze those trade-offs. And essentially, that's one of the core aspects of our book. As a matter of fact, it's our subtitle, Modern Trade-off Analyses for Distributed Architectures. And a matter of fact, all the stuff we talk about in our book, from the fact of what a lot of software developers have to face as choices in terms of maybe what sort of migration pattern to use, or service granularity, maybe it's async or sync, or what kind of communication protocol, what sort of contract should I use, loose or strict? Should it be a JSON schema? Should I use XML? Shared services versus libraries. How do I deal with reused code in a distributed architecture? How do I manage workflows and transactions? These are all sections, chapters in our book that architects must be able to discern the trade-offs of, but also developers should know and weigh in on those trade-offs as well.
I mean, this book is the more advanced of the two, between the fundamentals of software architecture and architecture of the hard parts, obviously. But this book, I think, helps explain to developers and non-architects why architects are always so grumpy. Because there are no clean binary answers. We say early on in our book, sorry, but this book has no answers in it, because we can't give you generic answers in software architecture. That's what makes software architecture so difficult. What you have to be able to do is figure out how to analyze trade-offs yourself. And so that's what we try to do. And that's valuable because, there's this tendency in software development to look for magic solutions and silver bullets, and they just don't exist. We used them all up, 20 years ago or something, and you can't find any anymore. And so being clear-eyed that, everything in our world is a messy trade-off that gets you to that analysis phase much more quickly, and you don't waste as much time looking for, a single solution that will solve all your problems.
Yeah, indeed, Mark and Neal. It's hard because there are so many options out there. And I think we have a very interesting question from Meena. And she says that architects in big organizations are asked to define the end state. I can smell the problem here. How do we convince the management that incremental architecture is what helps and there is no end state? I think that's a fantastic question. Anyone wants to take that?
I wonder who should answer that one.
Well, there was a great quote not too long ago. I believe it was from the Google engineering folks who said that programming is something that is just coding, but software engineering is coding over time. One of the traps that we sometimes find architects falling into is this treating architecture like a math equation. That, if I could just get in front of the whiteboard and concentrate enough, I could finally reach this ultimate architecture and then drop the whiteboard marker and walk away and never have to think about this again. But you never get there because the thing that you're trying to model is not a steady state. And so how is the thing you're building that models this messy business ever going to reach a steady state? It's wishing for something that would be nice because, if one of those two things would stop, it would let us catch up and, actually fix some technical debt and that sort of stuff. But that never happens either. So, but I think it's important to view things as a continuum. And in fact, one of the even sub problems that I see people falling into, in fact, the client I'm working on right now is falling into this problem of thinking that we really need to seriously gather all the data up and organize it all into one big master, thing of all the data in this huge big system. And I asked them, why? You're never going to need all that data together in that big giant footprint, and getting all that state together is almost impossible. It's like, yeah, but it would be so organized. It's like, but to no end. It's a continuum. It's always going to be shifting and changing. So I think, we're modeling shifting and changing things, and you have to model that in architecture. So that's part of the reasons why you have to be incremental. And in fact, one of the things that Mark and I stress a lot in this book is iterative design in architecture. One of the really difficult things in architectures like microservices is nobody that I know, as talented as they are, can just look at that problem and have the proper design fall out of their head. You have to be able to iterate on it. So we actually show some techniques on, using lines and boxes and iterating on design, thinking, well, if I change this from synchronous to asynchronous, how is that going to change some of the characteristics I care about? That's the kind of trade-off analysis that we're talking about. And, that's really the secret. We often get this question about how do Agile and architecture go together? Well, that's how they go together is iterative design. You can iterate on design before you have to start writing things and then iterating on coding.
Absolutely. I believe change is the only constant here. And there is another question from Suresh. Everyone wants to be a software architect, I'm sure, Suresh, but he wants to be a software architect in 3 to 5 years from now, and probably is looking for some forums where he can get mentorship and guidance. Mark and Neal, would you want to share some resources, places where people can?
Absolutely. There's two that I can think of that immediately come to mind, and that is a great book called The Fundamentals of Software Architecture. I've heard it's really good. And also that follow-on book is really good to understand trade-offs called, I think, Architecture, the Hard Parts. But no, I'm being flippant. However, I will say, though, one of the things, if you're looking for a 3 to 5 year, which, by the way, is great insight, because you don't become a software architecture or a software architect overnight. And I think that kind of time frame really gives you a lot of time to try to hone some of those skills an architect needs. As a matter of fact, one place to see kind of a roadmap, at least my perspective as a software architect of a roadmap, is in my website. I have this Software Architecture Monday, these little videos. As a matter of fact, I did a 6-part series starting in lesson 86 on becoming a software architect. And it really talked about all those facets that you need to start gaining experience in. And because I had that lesson, as a matter of fact, let me put it in the chat here. There we go.
Now, while he's doing that, this website, developerarchitect.com, which Mark runs, is probably the preeminent resource for someone who's trying to make that transition, because it has all these short lessons, because you're trying to gather breadth to become an architect. And that's a great way to incrementally gather your breadth. So go ahead, Mark. while you were typing.
Anyways, yeah. But regarding your idea of forums and stuff, the architecture forums, ones that I belong to, for example, in LinkedIn, used to be fairly active. They've kind of started waning. The enterprise architecture forum is still one that I see somewhat active. It might be a little higher level than kind of starting out as an architect right from developer, but at least it does give you that sense of, what are architects posting as issues or thoughts or just things they're thinking about. But there are quite a few, as a matter of fact, in LinkedIn, for example. But like I said, a lot of them aren't as active as they were, say, 5 or 10 years ago. Yeah.
Fair. I think there's a very beautiful question from Ane Onkar. As a solutions architect, I believe I'm on my way of becoming an ivory tower architect. And how to avoid this trap, or how do you avoid it and stay grounded in technology? I think that's a wonderful question.
Yeah,
that is a great question. And in fact, it reminds me, I was talking to a group of architects at a company not too long ago, and it turns out that there was an office building in their city that had the nickname of Ivory Tower, and they were going to move the architects into that office building at one point. They said, please don't move us into the Ivory Tower, because everybody, it's just too apt, and so they talked them out of it and moved into other office space. So, I mean, this is a common problem that architects face, because as soon as you become an architect, you realize that there are 100 or 1,000 things pulling at your attention all the time. And it's really difficult to stay really grounded and in touch with what's going on. And so that's something that you have to be diligent about. But you also, so one of the ways to do that, I think, is you never really want to be on the critical path for anything, because you get interrupted and pulled away. But one of the things that I like a lot that works well within Thoughtworks is selective pairing. So as an architect, you can pair with people on the project and spread around your, different parts of the project on the front end, the back end, et cetera. And you're not on the critical path, but you're getting exposure to the code base, so that you have, I think that's critical as well, because the further away you are from the code, the harder it is to make contextualized decisions about things. And that gives you ready access to lots of the parts of the code base without becoming a bottleneck. The other thing that's important too, though, is that you have to retreat a little bit to an ivory tower. One of the things that Mark and I talk about in the fundamentals book is this mind shift that you have to make when you become an architect, because the way that you get to be an architect is by exhibiting technical excellence and depth of knowledge about things. But as soon as you become an architect, you really want breadth more than depth. In other words, it's better to know that there are 5 concurrency libraries that can solve this problem, rather than to know deeply how to solve it in one of those concurrency libraries. And so there's a little bit of broadening that you need to do, because it makes you a better architect. And so you may keep some tendrils of expertise, but I think that broadening is important. But don't broaden so much that you lose context of what you're working on a daily basis. So that's part of the challenge of being an architect, is you're the nexus of so many things. That's another one of those things you have to manage.
Yeah.
So,
I'm sorry, Mark, go for it.
Oh, I just wanted to interrupt you just really quick, Vanya. I apologize, but it's just it's gnawing at me, this question in the chat. Although it'd be good, everyone, if you can post your questions in the Q&A, but this one in the chat just is really gnawing at me, and it's a 2-part kind of question. But it's what do you say about the notion there is no software architect title or position in the most innovative tech companies? This is no mistake. Is it true? Or do you agree that most innovative companies don't have architects? The reason I want to really address that question is because what we're really getting at is the role versus title. And there are a lot of companies, as a matter of fact, there's a lot of companies I work with that don't have a formal role of an architect. However, or a formal title, I'm sorry, of an architect. However, they have individuals that are acting as the role of the architect. And so what I'm encouraging to think about in this is getting more away from the title of software architect and more about the exercise and activity of thinking architecturally, thinking like an architect. In our book, as a matter of fact, that first question, I think it was, or maybe it was the second one, Vanya, you asked about why should developers read our book that we're talking about here, the hard parts. We outline almost a dozen different, extremely complex trade-off analyses and discussions for various aspects of distributed architecture. And I would push it back to say on the person asking the question, or any company, to say, who's making these decisions? Who's identifying the underlying architectural characteristics and qualifying those? Who's making the major architectural decisions about should we even do microservices? Somebody's making those. And that part, at least in my belief and feeling and experience, is necessary in order to develop systems. I hold the opinion that you cannot develop a system without having an underlying architecture, unless, of course, there is an exception. And I love this. I'm going to turn it over to Neal to talk about, when would you need an architecture, Neal? Woof, woof.
Well, I mean, I think the architects that
I hope you got the lead in.
Yeah. I think the architects at Netflix would disagree that you don't need, that there are no architects in innovative companies, because they invented a bunch of engineering practices. So yeah, I don't agree with that at all.
I was thinking of the doghouse analogy, Neal. That
yeah,
it's such a good one that you say. In other words,
I don't know what you're doing.
Well,
yeah, I know what you're talking about. So yeah, I was actually going to talk about that.
Good.
And lead into that. So yeah, I mean, and a lot of this depends on what you're trying to build and how much effort it takes. So, and this is the doghouse analogy that Mark is referring to. So if you're going to build a doghouse, you don't need to hire an architect. You go buy some wood at the hardware store and nail it together, and your dog's probably pretty happy to have a house. But if you're building a 50-story office building, you don't go to the hardware store and just start nailing it together. You got to do some planning, elevators and plumbing and building sites. So if you're building a simple little website for your kids' football league, you don't need an architecture. You download a framework and you bang it together on a weekend. If you're building a highly scalable, highly available site that has low latency and all these other characteristics, you got to do planning. You have to have architecture, whether you call the role architect or, Zen guru number 5 at your tech company because you're so innovative. Somebody's making that decision about how you build stuff. And so that is architect, whether, whatever you call it at your particular company. That's like saying innovative companies don't have accountants. Yeah, they do.
I really like that analogy, Neal. I think need to look at this as a role rather than as a title, because somebody has to wear that hat. Now it could be a developer on your team or somebody else, but I think that's a beautiful way to summarize that. And I want to ask another question because there are a lot of questions pouring in the Q&A. What is the relationship between MVP and architecture? Should we, spend months in designing and discussions and creating consensus about our architecture, and how difficult it is to change if we over-engineer certain things at the very beginning? So if you want to shed some light on how do we approach an MVP while we are starting on our product development journey?
Sure. I mean, so an MVP implies that one of the architecture characteristics you're dealing with is feasibility. How quickly can we get this out? Because, we're trying to do a startup or something like that. And there are always trade-offs that you have to make here. This is where the iterative design that Mark and I are talking about is so valuable, because you can't just start throwing code at the wall and then hope that it'll be performant and scalable and all those other things. But you also can't spend a year and a half doing, in-depth analysis before you start working on stuff. So this is where iterative design comes in. So, one of the things we talk about in our fundamentals book is you basically, the first parts of architecture is you do domain analysis, and then you analyze architecture characteristics or non-functional requirements, and then those together go into your initial architecture style you're going to use. And then from there, you can start doing iterative design on, is this a hybrid, and what parts do I need to hybridize, and do it sort of on paper and lines and boxes until you can get enough to actually start building some stuff. And this is where it's always, the sooner you start building things, the more likely you are to have to come back and address something later that you didn't anticipate, because how many times do you ever start a software project where something unanticipated happens as you start building it? Oh, that's right. Every single time you start building a software project, that happens. So, you have to expect that's going to happen. And no amount of planning is going to solve that problem either. So there is definitely a sweet spot on, getting things done, which is why you see so many companies strategically compromise on some architectural concerns in startups, because if they don't make it to the finish line to get to market, then they're not going to survive anyway. So Twitter is probably the most famous example of building something to get speed to market, was the number one guide, and then they made it to market and then had to painfully rebuild it while everybody watched them fail, but they survived. And you could argue that if they had built their ending architecture first, then we wouldn't be talking about Twitter, we'd be talking about some other small message service that had captured the market. So sometimes it's quite strategic to do that. And again, that's why the role of architect is not an easy job, because that's a great example of many forces coming together to affect those decisions.
Fair. Among, there's a question that you would like to answer, which is about, what is your advice on the hard part balancing trade-off between performance versus security? I guess everybody's favorite question when it comes to using microservices in a distributed environment.
Yeah, I love that question, because it involves several parts of the context of this whole webinar, which is hard parts and trade-offs. And so I've been anxious to answer that, or at least address it. I don't know if there is an answer, but at least I can address it. So when we talk about trade-offs between these architectural characteristics, these ilities, sometimes they are oil and water mixtures, which makes things hard. In other words, performance and security, is a great example of what you called out. And when I say oil and water, these sometimes are opposing forces. Generally, the more secure you make your services, the less responsive or performance you will have. The more performance you want, generally, the less secure you can make things. So how do you go about addressing this trade-off? My advice on this part is a tip that both Neal and I have about modern trade-off analyses. And that is to avoid this all or nothing situation in a trade-off. In other words, when you talk about a microservices ecosystem or environment, we tend to think, well, which is more important in this environment, security or performance? And in many cases, that's the wrong question. It's what parts of our system need more security as a trade-off of performance, and what areas of our microservices environment do we need that sheer raw performance or responsiveness. And it's so important in those particular services that we're willing to trade off a little bit of security to get that. And so my advice is to not look at these things as an all or nothing, a holistic view, but rather within a specific context, because what you will find is that you will be mixing this trade-off balance everywhere in your system. And so that's really the advice I can give on all of these kind of opposing forces. Performance and abstraction. Oh, it's another great one, which has the same answer, as a matter of fact.
Thank you, Mark, for answering that. There is another aspect that I want to draw our attention towards, which is the the big debate between being a specialist and a generalist, right? And when it comes to software architecture, it would be so interesting if you both can shed some light on how should people approach this. Is being a generalist better way to approach the breadth of architecture, or being a specialist?
Well, I have another analogy, as I do for so many of these questions that come up all the time. Back when I first joined Thoughtworks 17 years ago, the common mantra at Thoughtworks was that specialization is for insects, that everybody be as generalist as you possibly can be. But then a problem happened. Our world kept getting more and more and more complicated. And I remember when Thoughtworks hired our first user experience designer and our first data scientist and these other really specialized roles and so here's my analogy. So back in the 1850s or so, a doctor meant that you had a medical bag with a jug of whiskey and a hacksaw, and that's pretty much it. There wasn't a lot of medicine around. And the Civil War in the US, actually, there were massive innovations in surgery, and that really kicked off what we think of the modern medical profession. That's when they learned about sterilization, a lot of these key things. Not too long ago, I say that, about 5 years ago, I sat on an airplane and started chatting with my seatmate, and it was someone who specializes in one type of blood disease. So that's how specialized medicine has become, and we are on the same path. At some point, even in our lives, the software universe was small enough that you could be a pretty broad generalist and get, and touch just about everything in our world. But our world keeps getting chaotically more complex all the time. And so, part of what you hear is try to be T-shaped, try to be a broad generalist and have some areas of expertise. And that's, I think, what you have to do now, because there's just too many things to be expert in, because they're all, each of them is an expertise that you can dedicate all your time to. And of course, you only have one lifetime's worth of time to dedicate to stuff. So I think it's part of the natural evolution and maturity of the software engineering field that the specialization, I think, will continue to happen, because the things that we're trying to do are going to continue to become more and more specialized.
Yeah. And as a matter of fact, to kind of follow up on that, from what Neal's talking about, there is some cautionary tales and my advice is just to sometimes exercise caution with that specialist kind of role. Although you become this really targeted expert, like Neal was just describing, you significantly shrink your availability or your prospects or opportunities in the job market. And so this is one of the dangerous slippery slopes of getting too specialized in a particular platform technology or architecture. I kind of echo what Neal's saying about remain broad, but it's okay to really go deep in some particular area that you're really interested in, but still maintain that breadth and as a kind of generalist. And that really does serve both of those situations, opens your opportunities in the job market, and not only for the job market, but also opportunities at work to branch out, or especially as a consultant to get projects. But yeah, that specialization is sometimes a cautionary tale. Yep.
Thank you.
Well, and one follow up on that, a great way to kind of osmose a little bit of that expertise is pair with a data scientist or someone in one of those rarefied roles, and start picking up some of the general knowledge so that you're not just completely in the dark.
Yeah. Don't be afraid to stand on the shoulders of giants.
That's a good one. That's a good one, Mark. Neal, I see that you want to answer a question from Ikaran. I think there's a comparison of when we want to practice coding, we do coding katas. And what is your view about architecturing katas to hone that muscle for designing good systems?
Well, it's a great question, and one that we obviously would hone toward directly, because years ago, so the thing that led to our fundamentals book is that Mark and I observed probably a decade ago now that, software architecture is a a role that a lot of companies need. And there's no really good curriculum for how to become a software architect. And we started kind of lamenting that fact that, there's not good course material to do that. So that's when we started putting together the material that eventually became the Fundamentals of Software Architecture book. But it started out as live classes that we would teach, and we wanted to have exercises because, the way to learn something is actually apply it. And we started using this technique that this friend of ours developed now 20 years ago, this idea of architecture katas. And in fact, there are a bunch of them on our companion site for fundamentals of software architecture.com. There's a whole section of architecture katas there, but which is exactly as it says on the tin. It's a way to practice that trade-off analysis in architecture, to analyze non-functional requirements and domain as an exercise, because the question posed by the creator of this idea was, how do you get better at anything in life? Well, you practice. How often do you get to practice designing new architectures? Almost never. So how are you supposed to get better at it if you never get a chance to practice? So that's this opportunity to practice, just like those other kind of katas. But the other kind of katas, like a coding kata, is very concrete because it has a yes or no answer. And architecture katas don't have a yes or no answer because it's really more about the exercise than the outcome. Now, what we suggest people do is gather a small group of people together and work through the kata, and then find an architect in your organization to grade your work. And by grade your work, what they're doing is, did you do a good job of identifying the important parts of the architecture that need to be there? Did you miss any important things? Did you over-engineer something? And so that's what it means to be correct. But it's really more about exercising those muscles and becoming better at noticing those things is the real benefit of the exercise, not the outcome. But we highly recommend, which is why we put a bunch of them on our website. We highly recommend that people use this, because one of the things we say at the end of one of our training classes, in fact, is that architecture is not a spectator sport. You have to do it to get better at it. And so find a way to do it, whether it's a little kata experiment or at your job, or you can annoy your spouse by trying to do some software architecture at home, but you got to do it somewhere.
Absolutely. I love that advice, Neal. I think muscle grows when it's put under tension, and your architecture prowess is going to grow if you're going to put it under practice more and more. Fantastic. There's a very interesting question that Mark would like to answer, which is, results of some architecture decisions are visible after we invest in that path for some time. And how do you sort of manage the trade-off between decisions and speed, keeping in mind the time and money aspects as well? That's a wonderful question from Dipanjan. Mark, you want to answer that?
Yeah, I love this question. It has to do with architecture decisions. And as a matter of fact, all of the anti-patterns that exist. And so this question is actually relating to one of the first anti-patterns that exist in architectural decision-making. It has a funky name, and it's probably not good transferable based on cultures. But the point is, what it is an architect that basically hesitates to make a decision, because you are right. These decisions are visible. You make a decision, everybody sees it. And what if you're wrong? And this is an actual anti-pattern in architecture. It's called covering your assets anti-pattern. But what it really means is that an architect hesitates to make a decision. And you are absolutely correct in your question. What happens is it slows things down. One of the ways of overcoming this and managing this trade-off is something called the last responsible moment. Now, you don't want to be too hasty, because you're correct. Major architectural decisions are highly visible. And if you make a too hasty of a decision, you have to keep changing it, people lose trust in you. And sometimes that's an expensive change. However, you don't want to wait so long that it stalls everything, because people will just start moving on without you, and you're also seen as non-effective. That trade-off of the balance has a lot to do with being able to have enough information that you feel that you can actually justify your architecture decision. You see, if you provide, and this is why we love architecture decision records, because it's a great way of documenting an architecture decision along with the justifications and the consequences or implications after you've made it. If I can justify properly and effectively an architecture decision with the information I currently have, usually people will agree with that decision. A lot of times we change the decision because we do have additional information and context. And in that case, there's a rationale for making the change and a justification for the new decision. And so it really is all about making sure you have enough information, but also, most importantly, that justification and documenting your trade-offs that you've done.
Yeah. Cool. I think no one can understate the importance of ADRs on any large program, Mark. Thank you for bringing that awareness once again. Neal, I'm so glad you marked that, because I wanted to ask that question as well, which is a very important one about how can architects influence organization culture? If you're talking about trade-offs, it's practical. Some trade-offs will not work or provide benefit which you anticipated because they are largely dependent upon organization culture. So how do architects influence that?
Well, I really don't understand this question, because when you become a software architect, you're supposed to be issued a crystal ball so that you can tell the future and not have to worry about it. So I don't. This is the problem, of course, is that when you're an architect, you're often making very complex decisions that you don't know the answer to and cannot anticipate what the outcomes are. And this is why I wanted to answer this question, because I think too often architects believe that they are supposed to find the single magic solution to a problem within an organization. But here's the problem with that: you can't. One of the things that a phrase that Mark is famous for that I've kind of stolen is that software architecture is the stuff you can't Google. When you're a developer, you get really good at Googling for, exactly what part of the stack trace will get you the best hits in Google to figure out, what's going wrong or what's misconfigured. But try sometime to type in the Google, to Google, should I use orchestration or choreography for the accounting workflow that I'm working on? And Google's not going to give you any good advice, because Google doesn't know anything about your software architecture. That's the thing that makes decisions in software architecture so difficult, is that there's nothing generic in software architecture. Think about the software architecture in the organization you're in. It's this messy combination of good things and bad things, and things we like and things we don't like, and things we're stuck with, and we're not even sure where that came from, but we still have to connect to it and get something out of it. And that's what software architecture looks like. And so imagine that. So what are the chances that the problem that you're trying to figure out, what are the chances that someone else has had this problem and they figured out a solution to that problem, and they wrote a blog entry about how to solve that, and you searched and found it? I mean, that the Venn diagrams are getting really, really small and tight here. And so your job as a software architect is not automatically come up with the best solution that solves all the problems and has no negative trade-offs, because those don't exist. The thing that I keep telling architects within Thoughtworks is that's not your job. Your job is to get really good at doing objective trade-off analysis, because at the end of the day, the thing that's valuable about software architect is to be able to go to decision makers and say, here are the possibilities and here are the trade-offs on either side. You make an informed decision. And there's no guarantee that that decision is going to be right, but there's a guarantee that you've done due diligence and learned as much as you can about the objective trade-offs, so that you can, in fact, move forward with open eyes and say, okay, we accept some of these trade-offs and move forward. And then if we got it wrong, then, we try to address that as quickly as we can. But, nothing is perfect in this world. And so you can't really be in an organization that tries to punish you for the world changing in an unexpected way. That's just not a tenable position to be in. But I think, you can defend your position by, hey, this is the trade-off analysis. What was incorrect about the trade-off analysis? That's something that you can address and come back to later and say, we literally did the best we could given the knowledge we had.
Absolutely. There's an interesting question again on the depth versus breadth theme. I think you folks alluded to that in the beginning. And there's a question about when somebody's transitioning from an engineering position to, again, a position to an architect position, how do you suggest that they make that change? Should they spend some amount of time in some domain, or should they change their domain from their existing team? How should they approach this transition? Any advice on that?
Yeah, I think to starting out on that, maintaining technical breadth is actually not overly easy. We try to maintain our technical depth, and we have a tendency that if we try to understand something, we need to understand it all the way through. And if we kind of only say, well, I'd like to learn about this framework, but I only want to know just a little bit. If we continue to do that, we actually start to get what's called the imposter syndrome, where we feel like we know a lot about a lot of things, but not much in depth. The common phrase is jack of all trades, and a master of none. And that's called the imposter syndrome. But it turns out, though, that it is much more valuable as an architect to know, as Neal was referring to earlier, 10 different caching technologies and the pros and cons and trade-offs and characteristics of each, than to how to code all of those. But to come back to the kind of the core of the question, maintaining that technical breadth, starting out is really just trying to understand or learn things you've never heard of before, become familiar with buzzwords that you hear. If we throw some word out that you've never heard of before, just Google it, research it, find out what it is. If I say, well, we had a problem with the whole issue of Spectre, and it's like, Spectre, what's that? And if you start to listen, if you're in a meeting, even, by the way, not just technical, but business terms, this starts to create an awareness, and it slowly starts building up your vocabulary of things that you're familiar with. What I usually do to start enhancing this technical breadth is I become familiar with terms. So if somebody throws it out, I know the context that it's in. But within certain areas that I choose to have somewhat of an expertise in, as opposed to just a familiarity, I will then just take a couple of minutes every morning to just start looking at it a little further. But I also, even me, who I'm still maintaining my technical and developing my technical breadth, I don't try to rush it because it does take this exercise in just consistency and time and continually just learning new terms, learning new frameworks, just in terms of even what they do. So.
Yeah, thank you, Mark, for providing insights on that. Neal, I see that you want to answer a question about the full stack architect. Are there categorizations like backend architect, mobile architect, and so on and so forth, or it's a full stack world? Please. Yep.
It's a great question, because it's a great example of how little consistency we have in the world of software architecture. Some organizations have dozens of different kinds of architects. Some just have architect as a role. Some have back-end architect and mobile architect, embedded architects and solutions architects and domain architects. Yeah, but it really depends on the size of the organization, how they want to organize stuff. So I think, regardless of how many of these roles you have and what you call them, the question is, are they actually doing useful work, or is it just sort of a bureaucratic placeholder for something? So, and of course, in most places, if you're a very small company, you can be a full stack person who knows everything about, everything from top to bottom. But, as you get increasingly complex, when you're in a 10,000 person or 100,000 person organization, you have enterprise architects and integration architects and domain architects, and it's impossible to be truly full stack in that world. So, a lot of this depends on the size of the organization and how they consume architecture. So that's another one of those really messy things, that there's no real standardization. In fact, there's not even a standard architecture role in our industry. In most places, it's like, well, you've been around here coding for a really long time. You seem to do a good job. And we've worked through all of the senior and all those titles. So we'll just start calling you an architect. Is that okay? It's like, yeah, that sounds good. And so, I mean, that's basically how that, I mean, there's no certification for a software architect. And so there's no standardization of the titles. So it's just all over the map. So.
As a matter of fact, I guess somewhat related, but especially related to the previous question, is a question in the chat about how do you keep maintaining the passion of coding while increasing your technical breadth? And boy, is this a multifaceted question. Should architects even code? And if you have a passion for coding, does that mean you shouldn't become an architect? So I love the two-pronged question here, but in fact, yes, it generally is true, not always, but is true that you do less coding as an architect, but it doesn't mean that you do no coding as an architect. And let me give you some of those examples about how to maintain the passion of coding and still enter into the whole architecture role. And the first of those is what was suggested actually in the question here about doing POCs. A lot of times I may have a trade-off that I need to analyze. What better way to really see that trade-off than to just code an example in each? Because by doing so is a win-win. Actually, it's a win-win-win because not only am I coding, but I'm also teasing out some of those trade-offs. And the other win is, as an architect, if I need to make a certain decision, I'm actually seeing the implementation concerns associated with a particular decision. Now, here's a good words of advice for all of you. When you do a POC as an architect, unless you know that you're at home and you're going to immediately throw it away, and I mean, hit delete, take the opportunity to write the best quality production quality code that you can. And here's why. Two reasons. First, it gives you practice of just not slapping together code, but actually writing some good quality code. Number two, I can't tell all of you how many times I've done a POC, I've showed it to my team. It becomes a part of the reference architecture that goes into the Git repo and becomes part of production code. Now, my question to you is, as an architect, do you want the sloppiest, worst code you've ever written to be your representative sample in the Git repo? The answer, of course, is no. But the other thing I do frequently is I love writing productivity tools for my development teams. Something that I see that I can automate where my development teams are focused on the functionality and working on stories. So I'll take the opportunity to just write productivity tools, command line interfaces, maybe simple screens that perform some sort of automated function. That's coding. These are all great examples. Even, are you ready for this one? Code reviews. I know it sounds silly, but if you end up in an opportunity as an architect where you can't code for some reason, maybe restrictions on a particular project, your rates, whatever it may be, offer up to do some code reviews. You're not necessarily writing the code, but you're involved in reading the code. It's also a great way of actually ensuring compliance with some of the architecture decisions that you've made.
Absolutely. Automating the pain away, Mark. Automation to the rescue. Absolutely. We have only 3 minutes left. I have picked up a question because you gentlemen did not indicate which one do you want to answer next. And I want to ask, what are your suggestions and advice for architects to tighten security, specifically in a dynamically evolving cloud solution ecosystem? I think that's a great question.
It is a great question. And this is something that touches on the book I wrote right before Fundamentals of Software Architecture, which is building evolutionary architectures, which we're actually working on a second edition of. But that's this idea of an architectural fitness function, kind of the unit test equivalent, but for an architectural characteristic like security. So security is always one of those things you have to think about as an architect, whether it's explicitly called out in requirements or not. And you have to be really diligent about security. So, as you move to new deployment environments, you need to make sure that you're not opening up ports that shouldn't be open. And you also need to make sure that you have ongoing checks for those kind of things. So one of the problems we talk about, one of the things that fitness functions address is that when you do the same thing over and over, it's easy for things to fall through the cracks. And, for forgetting to turn off debugging ports. And so having automation, here's automation again, that keeps coming up when we talk about software, but having automated checks and governance on all those critical security things is nice, because you make arbitrary changes. You don't know when you might open up something, and having a check that's always running as you check in your code that makes sure you haven't made that security mistake is a way to protect yourself in the modern kind of automated governance way.
Yeah. And I'll throw in just a very quick advice that I usually give, especially in distributed architectures. And that is, I'm not allowed to say the word always. I usually assume that every endpoint to every distributed service or system will be secure. That's a base assumption. However, the thing that varies is the level of security for that particular service or that particular endpoint. And when I say level of security, is this a simple validation of a JWT, or is it a reauthorization? That makes a big difference in terms of what we talked about before with that trade-off of performance versus security. So in tightening the security, again, we're dealing with the trade-offs of now potentially performance and responsiveness due to that sheer latency of reauthentication, potentially generating a new token, maybe even reauthorizing, switching over to a different zone or domain. But that assumption that everything will be secure now brings the conversation more to what level of security it should be there. So that's usually my go-to advice.
Thank you. Thank you so much, Neal and Mark. I think we have just hit the time mark as well. And I would like to take this opportunity, because it's very late for both of you, but you still stayed up so late to share your information about this wonderful book. And I just want to flash it on the screen right here. So there's a woodpecker here. Mark, do you want to very quickly talk about the relevance of having woodpecker on the cover?
Well, sure. Let's close with that, because usually authors are not allowed to choose their own animals, but we kind of ask, can we do it? Well, so originally Neal wanted a dragon because Neal's response was, well, we're kind of slaying dragons. And of course, our publisher immediately said, yeah, no. And we knew we were probably going to get a bird, and my spouse is a birder. And so I was telling her about this, and she said, well, what's the title? And I said, well, Architecture of the Hard Parts. And she said, oh, that's easy, like a woodpecker, pecking away at the outer hard parts to the soft inner center. And I said, that's exactly what we're doing in the book. And O'Reilly loved it. And so we got the unique treat of being able to kind of pick our own animal on the cover, which was kind of neat. So that's the significance of the woodpecker. We're chopping away at those hard parts to make things softer and easier for all of you in architecture.
Thank you so much, Mark, for sharing that amazing story. And I would like to thank all our listeners and audience for tuning in at this time to understand what Mark and Neal had to share with us about this wonderful book. So do order your copy, right? It's available out there. Mm-hmm. And there are a lot of interesting resources on the thoughtworks.com website as well, on the landing page, which I'm unable to paste in the chat. So if Shani, you can help in pasting that link here so that everyone can have a handle to that. There are a lot of resources at this page available for all of you. So feel free to look at them, and thank you so much and have a good day. Bye, everyone.
Yep. Thank you all for coming, and thanks, Vanya, for a great job of hosting us.
Yeah. Thank you.
Thank you. My pleasure. Bye.